Hello and welcome to the CCAC Methane Action Program Background Training video series. My name is Nathan Borgford Parnell. I am the Science Affairs and MRAP Coordinator for the Climate and Clean Air Coalition. In this video series, we will be covering each of the 5 MRAP building blocks in detail, providing important background and context and examples of good practice to help countries begin their journeys towards developing national methane roadmaps and achieving rapid mitigation of methane emissions in support of the Global Methane Pledge. The Global Methane Pledge, first launched in 2021, now includes 150 participating countries working towards the collective goal of reducing global methane emissions by at least 30% below 2020 levels by the end of the decade. The Climate and Clean Air Coalition is a key implementer of the Global Methane Pledge and serves as the first point of contact for the GMP signatory countries. In this role, last year, we launched MRAP as a landing platform for GMP countries to join a collective effort, support the development of national methane roadmaps through a common planning and implementation methodology, and connect to expertise and support from the broader CCAC community. Drawing on the CCAC's decade of experience, MRAP supports the development and implementation of transparent and consistent national methane roadmaps by breaking the process into 5 core building blocks. The program is designed to meet countries where they are and to help them translate their existing commitments and strategies into an implementable roadmap. In this video, we will be going through the third of the 5 roadmap building blocks, policies and measures. I will now pass this along to my colleague, Christopher Malley from the Stockholm Environment Institute.
Thank you very much. So why is building block 3 on target so important for including within national methane roadmaps? The first reason is that it clearly allows a country's contribution to achieving the global methane pledge to be understood. By setting a target on methane mitigation, those targets, country by country, can be aggregated to understand whether countries collectively have set targets that are sufficient to achieve the global methane pledge. It also provides clarity. It provides an unambiguous statement of how much methane a country is committing to reduce. It also provides clarity in terms of how much methane a country is committing to reduce compared to other greenhouse gases. In most cases within NDCs, targets are framed as an overall reduction in greenhouse gases. This does not provide clarity on how much methane contributes to achieving that overall greenhouse gas target. Setting a methane-specific target allows that clarity to be provided. It also provides the basis for tracking progress. When a target is set, we can put in place monitoring systems, as we talk about in building block 5, that provide the basis for assessing progress on methane mitigation and whether the targets that have been set are being achieved, are being underachieved, or hopefully are being overachieved. So how can building block 3 be included? There are different options for how a country may choose to state an emission reduction target covering methane. It may be that methane is simply included within the scope of a broader greenhouse gas reduction target, for example, within the NDC. Almost 90% of countries that have submitted an NDC submit one that includes this type of methane target, that sets a greenhouse gas reduction target, and that methane reductions are included within the scope of that target. The advantage of that type of target is that methane mitigation contributes to achieving the greenhouse gas reduction target set, for example, in an NDC. The disadvantage is that it's unclear how much methane mitigation is supposed to contribute to that target, how much that target has been set based on plans and strategies for methane mitigation. Some countries have clarified their greenhouse gas reduction target and stated, for example, within their NDCs, how much methane would be reduced from the full implementation of the NDC. This allows the methane mitigation ambition of the overall GHG reduction target to be understood. Other countries have gone even further and specified separate methane reduction targets that are distinct from the greenhouse gas reduction target. So rather than saying how much methane will be reduced from achieving the overall GHG reduction target, a country has set a methane-specific target. We will reduce methane by this amount. And then the final and most robust target for methane is a specific separate methane reduction target that is comparable with how the global methane pledge is defined. Setting a target that is consistent with reducing methane emissions by 30% compared to 2020 levels by 2030. Establishing a national target with that same framing, or the ability to convert into that framing, allows the target to be compared with the global methane pledge, and if all countries set targets in that manner, to aggregate those targets up to see where we are in terms of the level of ambition compared to the global methane pledge. In terms of countries and examples of setting those most clear targets, Japan and the nationally determined contribution of Japan sets the standard in terms of methane reduction targets. We can see from this table that Japan's NDC states that in 2030 they will emit no more than 26.7 million tons of carbon dioxide equivalent methane emissions, which is a reduction from 30 million tons emitted in 2013. This target is separate from other greenhouse gases, where we can see that separate targets are stated within this table, and allows the target on methane to be aggregated into the total greenhouse gas reduction target, which you can see on the first row. It also allows this target to be converted into a framing that is consistent with the global methane pledge, because we know what the limit, what the ceiling of methane emissions in Japan is in 2030 based on how the target has been defined. But other countries have chosen other completely legitimate ways of expressing methane mitigation targets. For example, in Uruguay, they have set two targets that are specific to methane. One is an overall objective to not emit more than 818 gigagrams of methane by 2030. And the other is a sector-specific target, methane reductions in the agriculture sector, to reduce methane emissions by 35% per unit of production for methane. As I said, many countries have not set methane-specific targets, but provide enough information to be able to understand how much methane will be reduced from implementing their NDC. Nigeria is a good example. The graph here shows Nigeria's greenhouse gas reduction target, 47% reduction in greenhouse gas emissions in 2030 compared to the baseline as a conditional contribution. They also state in the text that's on this slide that the full achievement of Nigeria's NDC would reduce methane emissions by 28% in 2030 compared to a baseline scenario. So achieving this overall reduction would lead to a 28% reduction in methane emissions. A key consideration when deciding how to define a methane reduction target or to state methane reductions is whether the emission reduction of methane has a robust basis. This links back to building block 2 on analytics. I encourage you to watch that video if you haven't. In building block 2, we outline how analytics and the ability to assess the emission reduction potential of methane mitigation measures can provide the basis for a robust target. The reason it provides the basis for a robust target is that the mitigation measures and the emission reduction potential of the mitigation measures show clearly which measures and the timeline and target for their implementation can be most effective in reducing methane emissions. It can show what contribution each mitigation makes to achieving an overall methane target. And so having the right analytics that inform the development of a target provides a more robust basis and a more realistic basis for setting a target, and provides a clear way in which that target can be implemented, because it forces you to decide which mitigation measures are going to be implemented to achieve the target. Many countries will have information already on methane mitigation that could inform targets, and the methane mitigation that is implied and implicit within existing greenhouse gas reduction targets. So nationally determined contributions, biennial update reports, national communications, mitigation assessments undertaken for climate change planning are all potential national sources of methane mitigation information. International sources from the Climate and Clean Air Coalition, they have assessed NDCs to understand what methane mitigation is embedded within them. And of course, there is the CCAC's methane technical assistance. There is a lot more information on methane roadmap development at the CCAC's website. Thank you very much for watching, and I look forward to seeing more methane roadmaps produced in the future. Thank you.